In this video, we are going to discuss how to find the measure of central angles and arcs along with the circumference and arc length. So to review, let's discuss the parts of a circle. You have a center of a circle, which in this case would be the center of O. You have a radius, which is the distance from the center to the outside outline of the circle. The diameter, which is the distance from one edge of the circle to the other edge of the circle going through the center. So don't forget, you must go through the center in order for the diameter. And again, the diameter is actually going to be the longest segment in a circle. And the circumference is actually the length going all the way around the circle. So if you think of circumference of a circle and the area of a circle, the circumference is the distance around. For example, if you have a person who is walking the distance around the edge of the circle, you would get circumference. Think of it as a perimeter. The area of a circle is the amount of space that is filled in inside the circle. Again, the circumference is basically the perimeter as you're walking around the circle, and the area is the amount of space that is filled inside the circle. So other parts of a circle, we've talked about radius and we've talked about the center, and then we have what is called the central angle. It is the angle that comes from the center and two radii are hitting the edge of the circle. When you have two radii that move out, they will create what is called a central angle. And this part of the circle that is bound between these two radii is what is called the arc. You would have the entire circumference, but this would be a piece of the circumference, and what we call it as an arc. The central angle and the arc are actually going to be equal to each other. The central angle is equal to the arc. For example, if this central angle is 60 degrees, then this arc is going to measure 60 degrees. If this angle was 40 degrees, then this arc would be 40 degrees. They will be equal to each other. You also can have a central angle if you were to go in the other direction. So instead of joining the two radii in the shortest distance, you can go in the other direction. And so if I was to say that this was the central angle between this radius and this radius, then this length all the way around would be considered its arc. So for example, if this central angle was 300 degrees, then this arc would be 300 degrees. So ways that we actually can use this sometimes is if we have a pie chart that discusses the percentages, like for example in this case of a movie budget, we can actually find what the angle measure is. So for example, if I wanted to know this angle measure, well, I know that it's going to be worth 36% of my circle. Now, just do not forget, the amount of degrees of a circle is always going to be 360 degrees, always. So if I want to know what the angle measure is of this arc or this angle right here, then I am looking for what is going to be 36% of 360. So if you multiply 0.36 times 360, you will get 129.6 degrees. If I want to know what 12% is, so therefore I want to know what is this angle measure right here, then I would do 12% times 360. And anytime you're doing a percent, you always have to make sure that it becomes a decimal. So 12% is the same thing as 0.12. So when you multiply 0.12 times 360, you will get 43.2 degrees. And that represents the arc length, or the central angle in this case, of these different measurements. Same thing with 21%, 4%, 5%, and the rest. If you were to take the percent and make it a decimal, which in this case would be 0.21, and if you multiply it by the fact that an entire circle is 360 degrees, you will get the actual central angle of each of those parts. So there are three different definitions you need to know. There's a minor arc, there is a semicircle, and a major arc. A minor arc is any arc or central angle that is less than 180 degrees. Any minor arc less than 180 degrees. A semicircle is exactly equal to 180 degrees, and a major arc is going to be any angle that is greater than 180 degrees. So for example, we are going to identify these arcs. This is saying to go from P straight to Q. So go from P to Q, it is going to be a minor arc, because it is clearly less than 180 degrees. Next, I'm going from P through Q to get to T. So I'm going from P towards Q, but I'm going to keep going around until I get to T. So I'm going from P all the way around to T. That is exactly halfway around the circle. So this is considered a semicircle because it is exactly 180 degrees, because that is a diameter. A diameter will create a semicircle. A diameter creates a semicircle. Next, I'm going from T to U and then to Q. So in this case, I'm going from T towards U and then from U all the way to Q. So I'm going from T, which starts there, all the way around to Q, and that is going to be a major arc because it goes past halfway. From T to P is halfway, and I go further to get to Q, so it is a major arc. The next one, I am going from Q to U and then to T, which means I must be going in this direction, Q to U, and then through U to get to T. So Q all the way through U to T, that is going to be a major arc. Next, S straight to U. So this is going to be the shortest distance of going from S to U. That would be a minor arc. Next, if I'm going from Q to T, so I'm going from Q to the shortest distance of T, that is also going to be a minor arc. Next, I'm going from T to U, which is from T to U, and then past that to P. But this is a diameter because it goes straight across, and so this is going to be a semicircle. And next, I'm going from P to U, so from P towards U, and then from U all the way around to Q. So I'm starting here, going towards U, past U to Q, and that would be a major arc. Now, there's something called the angle addition postulate, and in this case, you actually can do with arcs. So if I was to find the arc of from A to B, let's say it is going to be 60 degrees, and let's say the arc from B to C was 40 degrees. No, it wouldn't be 40, it'd be bigger than that. So let's say it's about maybe 70 degrees. So therefore, the angle measure of A all the way around to C would therefore be 130 degrees. So now let's do some practice of this. We're going from R to S. From R straight to S is going to be the exact same as the central angle. So the angle measure, the arc measure will also be 60 degrees. The central angle is equal to the arc angle. Central angle is equal to the measure of the arc. So PQR, we're going from P to Q to R. That is going halfway around the circle, so it is automatically going to be 180 degrees. Next, QSP. So I'm going from Q to S, and then from S to P. So I need to add these up. This is 40 degrees, this was 60 degrees, and then this was 120 degrees. So 40 degrees plus 60 degrees plus 120 degrees is going to be 220 degrees. Next, RP to S. So we're going from R to P, and then from P to S. So there's two ways you can do this. You can actually add all these up. From R to P is 180 degrees, and then from P to S is 120 degrees. So you could add these up and you would get 300 degrees. There is one other way to do this. I could subtract the one part that is not included. From R to S was 60. So if I'm basically going from R to S, but I'm going around the other way of the circle, I could subtract the entire circle minus the part that is not being used. 360 minus 60 will still give me 300 degrees. Either way, this will work. Next, from Q straight to S. So from Q to S, I'm going through R to S. So I'm just going to add this angle measure, which is 40 degrees, and this angle measure, which is 60. And together they'll give you 100 degrees. And last, the angle of QTR. This is an angle, not an arc. QTR is this angle measure. And that's the exact same thing as the arc measure. So your answer is going to be 40 degrees. Now, circumference. Circumference for a circle is going to be either 2 times pi times the radius, or it is going to be pi times the diameter. They mean the exact same thing, either 2 pi r or pi d. So for example, if we want to know how far the bicycle travels 100 feet, and we know that the wheel is 22 inches for a diameter, we want to know how many revolutions. Well, if you think about the fact that one revolution is going to be 2 pi r, or you could say that one revolution, which is one time around a circle, it is going to be the same thing as pi d. Okay? So I know that one revolution is going to be pi times 22 inches. So if I actually multiply, I will get the fact that 1 revolution is 69.11 inches. That is how far the wheel will travel one time. How far the wheel travels one turn around. And they want to know, how many times can this happen for 100 feet? Well, here's the deal. We're in inches, and that's 100 feet. So I'm first going to take 100 feet and multiply it by 12, and I'll get 1,200 inches. So we want to know, how many revolutions will the wheel make when it covers 1,200 inches? So we are going to take 1,200 inches and divide it by 69.11. And we will get roughly 17.36 revolutions. So the wheel will turn a little over 17 times in order to travel 100 feet. Arc length. So this is different than the measure of an arc. Arc length does not equal an arc measure. Okay? The arc length is the distance of part of a circle. Arc measure is the angle of that. The arc length formula. It is going to be the degree of your angle measure divided by 360 degrees, and you're going to multiply that by 2 pi r. So for example, if my angle measure is 60 degrees and my radius is 5 centimeters, therefore, if I want to know the distance of this arc length, I'm going to take 60 degrees divided by 360, and I'm going to multiply that answer times 2 times pi times 5. So I will get 5.24 centimeters. So the arc length going from this distance to this distance, think of a person who was walking on the edge. They will walk 5.24 centimeters of this distance. That is not the same as arc measure. The arc measure in this case is 60 degrees. That is the arc measure. The arc length is taking that measure, dividing it by 360, because you're finding out basically what fraction of this entire circle is this distance, and you're going to multiply it by the circumference. So to attempt one, the length is going to be the degree over 360 degrees, and you're going to multiply that by 2 times pi times your radius, and you will get 11.97 centimeters. The arc measure is going to be 98 degrees. The arc length is going to be 11.97 centimeters. The arc length should be some type of length unit. The arc measure will always be in degrees.